So here in this question, we have a rational function. We have to find its limiting value when x approaches 4. So let us begin by first doing a direct substitution. So we are going to replace x by 4. So we have 4 squared, which gives us 16, minus 7 times 4, which is 28, plus 12, divided by x squared, which is 4 squared. So that gives us a 16, minus 3 times 4, which is 12, minus 4. So we get a 0 over 0. So this becomes the case of indeterminate form. So that means x minus 4 is the common factor in the numerator and the denominator. So we have to get rid of this common factor. So let us begin by first factorizing the numerator, which is x squared minus 7x plus 12, by splitting the middle term. So we get the factors x minus 4 and x minus 3. Then we factorize the rational function in the denominator. So we get the factors x minus 4 and x plus 1. So let us replace these values into our function. So we have x minus 4 times x minus 3 in the numerator, divided by x minus 4 times x plus 1. So the common factor, which is x minus 4, is going to get cancelled out, leaving us with limit x going to 4, x minus 3 divided by x plus 1. So we substitute the value of x. So we have 4 minus 3 divided by 4 plus 1, which gives us 1 over 5. So this is going to be the limiting value. So here we have to determine the limiting value of the given rational function when x approaches 3. So let us begin by doing a direct substitution. So we're going to substitute the value of x with 3. So that gives us 3 squared, which is 9, minus 3 minus 6 divided by 3 cubed, which is 27, minus 3 times 3 squared, that is 3 times 9, which is 27, plus 3 minus 3. So we have an indeterminate form of 0 over 0. So that means we need to have a common factor. So we have the common factor x minus 3 in both the numerator and the denominator, and we have to get rid of it. So to do that, so let us start by factorizing the numerator. So we have x squared minus x minus 6. So we're going to factorize it by splitting the middle term. So we get the factors x minus 3 times x plus 2. Now we're going to factorize the denominator. So we have x cubed minus 3x squared plus x minus 3. So from the first two terms, we are going to factor out x squared. That leaves us with x minus 3. Plus, we're going to factor out 1. So we have x minus 3. So taking x minus 3 as the common factor, we have x minus 3 times x squared plus 1. So let us substitute this value back into our original function. So we have x minus 3 times x plus 2 in the numerator, divided by x minus 3 times x squared plus 1. So x minus 3 gets cancelled out from both the numerator and the denominator, and that leaves us with x plus 2 over x squared plus 1. Now we're going to substitute the value of x with 3, so that gives us 3 plus 2 over 3 squared, which is 9 plus 1. So we have 5 over 10, and the limiting value is half. So here we have to find out the limiting value of the given rational function when x approaches negative 2. So we begin by substituting the value of x by negative 2. So we have negative 2 cubed plus negative 2 squared plus 4 times negative 2 plus 12 divided by negative 2 cubed minus 3 times negative 2 plus 2. So that is going to give us negative 2 cubed will be negative 8 plus 4 minus 6 plus 12 divided by negative 8 plus 6 plus 2. So we get the indeterminate form 0 over 0. So this means that x plus 2 is a common factor in both the numerator and the denominator. So we consider the numerator, which is x cubed plus x squared plus 4x plus 12, and we're going to divide it by x plus 2. So we can perform either the long division method or we can go for the synthetic division method. So I've already discussed how to perform a synthetic division in worked out problem number 1 and worked out problem number 2. So you can go ahead and check out those videos how to perform a synthetic division. So I'm going to straight away give the result. So this will be equals to x plus 2 times x squared minus x plus 6. Then for the cubic polynomial in the denominator, we go about the same way and divide it by x plus 2 using synthetic division, or you can perform long division, totally up to you. So this will give us x plus 2 times x squared minus 2x plus 1. Now we substitute these values back into a rational function. So we have limit x going to negative 2, we have x plus 2 multiplied by x squared minus x plus 2 divided by x plus 2 times x squared minus 2x plus 1. So x plus 2 being the common factor, so it gets cancelled out. That leaves us with limit x going to negative 2. So we have x squared minus x plus 6 in the numerator divided by x squared minus 2x plus 1. Now we substitute the value of x with negative 2. So we have negative 2 squared, which gives us 4. So negative of negative 2 will be positive 2 plus 6 divided by negative 2 squared will give us 4. Negative 2 times negative 2 will be positive 4 plus 1. So we have 6 plus 4 is 10, 10 plus 2 is 12. 12 divided by 4 plus 4 is 8, 8 plus 1 is 9. So we have 3 times 4 is 12 and 3 times 3 is 9. So 4 over 3, this is going to be the limiting value of the given rational function when x approaches negative 2. So here we have to determine the limiting value of the given rational function when x approaches 1. So the first thing first, we have to substitute the value of x with 1. So we have 1 plus 3 minus 6 plus 2 divided by 1 plus 3 minus 3 plus 1. So that gives us an indeterminate form, which is 0 over 0. So that means we have x minus 1 as the common factor in both the numerator and the denominator. So we are going to factorize x cubed, the numerator x cubed, plus 3x squared minus 6x plus 2 by x minus 1 using the synthetic division, or you can use the long division, whichever way you feel comfortable with. Then this will give us x minus 1 times x squared plus 4x minus 2. Then we factorize the denominator, which is x cubed plus 3x squared minus 3x minus 1 by dividing it with x minus 1. So that should give us x minus 1 times. So we have x squared plus 4x plus 1. Now we're going to rewrite the rational function. We're going to write in terms of the factors. So we have x minus 1 times x squared plus 4x minus 2 in the numerator, And in the denominator we have x minus 1 times x squared plus 4x plus 1. So the common factors get cancelled out, leaving us with limit x going to 1, x squared minus 4x plus 4x minus 2 divided by x squared plus 4x plus 1. Now we are going to substitute the value of x by positive 1. So we have 1 squared, which is 1, plus 4 times 1, which is 4, minus 2, divided by 1 plus 4 plus 1. So we have 4 plus 1, which is 5. 5 minus 2 is going to give us 3. Then we have 4 plus 1, 5, 6. So we have the limiting value of half for the given rational function. So we have to determine the limiting value of the given rational function when x approaches positive 5. So let us do a direct substitution here. So we have 5 cubed minus 125 divided by 5 squared minus 7 times 5 plus 10. So 5 cubed will be 125 minus 125 divided by 5 square, which is 25, minus 7 times 5 is 35 plus 10. So this is giving us an indeterminate form, 0 over 0. So that means x minus 5 is a common factor in both the numerator and the denominator. So we have to get rid of it. So in order to do that, we are going to divide the numerator, x cubed minus 125, by x minus 5. So that should give us, so we're going to use the synthetic division. So we get x minus 5 times x squared plus 5x plus 25. Similarly, we are going to factorize x squared minus 7x plus 10. So here, what we can do is we can straight away factorize it. Since this is a quadratic polynomial, we can factorize it by splitting the middle terms, and that will be equals to x minus 5 times x minus 2. Now we're going to rewrite a rational function. So we're going to rewrite it in terms of the factors. So we have x minus 5 multiplied by x squared plus 5x plus 25 divided by x minus 5 times x minus 2. So the common factor x minus 5 cancel out. So we are left with limit x going to 5. So we have x squared plus 5x plus 25. So this is not 251, this is 25, divided by x minus 2. So we now substitute the value for x. So we get 5 squared, which is 25, plus 5 times 5, which is also 25, plus 25 divided by 5 minus 2. So we have 3 times 25 divided by 3. So that gives us the limiting value of 25.